Okay. Now we're going into permutations with identical items. So how many ways can you arrange the letters in the following words? So we know that it's number of letters over repeats. So we have 4 factorial. Oh, remember, it's the factorial, by the way. 4 factorial over how many repeats? We don't have any repeats. So instead, just going to write 1 factorial, which is the same thing as saying 1. So you can just say 4 factorial. And that is equal to 24 ways you can arrange the letters in the word fire. Now with apple, how many letters do we have total? We have 5. So 5 factorial over how many repeats? 2 p's. So 2 factorial, because we have to divide by how many different ways you can arrange those 2 p's, because 1 p is no different than the other p because they're identical. Instead, then we get 60 when you type that into your calculator. And then banana, we have how many letters? 6. So 6 factorial over 3 a's. So we gotta keep, those are the a's, repeats, but then there's also n's that are repeated. So we have to take account for those n's too. And that's how many ways you can arrange those 2 n's. And that is going to equal 720 over 12. So then that's going to get you 260. Now, how many different ways can you line up 3 Snickers bars and 2 Twix bars? So if we have 3 Snickers bars and 2 Twix bars, we know 3 plus 2 is 5. So that's how many total candy bars we have. So we have 5 factorial over, let's think our repeats. So if we have 3 Snickers, so 3 factorial times, and then how many Twix bars do we have? Or identical Twix bars, we have 2 factorial. And that is going to equal 120 over 12, which is 10. So there's 10 different ways you can arrange those 3 Snickers and 2 Twix bars because they're identical. Okay, so now with combinations. Remember, with combinations, order does not matter. And what I mean by that is, let's say that we had these 3 different juices. Let's say we had juice 1, juice 2, juice 3. Let's say we had orange juice, strawberry juice, if that's a thing, and lemonade. That is no different than if you were to pick strawberry juice, orange juice, then lemonade. So those are the same. So that's what I mean by the fact that order does not matter, because this arrangement is the same as this arrangement here. So that's why you end up dividing by the number of ways you can arrange them. Okay, so now that we know order doesn't matter, so we can draw our little slots. So we have 3 different juices being selected. Now we have 10 juices to pick from. So first, second, third. Remember, going back to permutations, how we have 10 to start out with because we have 10. 1 less is 9, and then 1 less than that is 8. And that's 720. But remember, with the fact that order matters, so we have to divide by the number of ways we can arrange those 3 juices, and that would just be 3 factorial. If it was 4 juices, then you would have 4 factorial down there. So these are the ways to arrange the 3 juices. And that is going to get you to 120 different ways. And again, you can also type that in on your calculator, as our N we said was 10 total, and our R was we're selecting 3. So we have 10 C, since it's a combination, so combination C, 3. And that's the same thing. It gets you 120. Now how you pick between the two. Remember, combinations are, it's like if they have the same ranking or position. So if like same role, And then permutations are if they have like different roles, like president, VP, treasurer, or if one was coming in first, second, or third, versus combinations. Remember, combinations are the committee type problems. Think committee, combination. Think permutation, president. Those president type problems with the different rankings. So that's when you're in combinations, if they all have the same arrangement, same role. Let's say if we're talking about a committee and there's Miss Harrod and Mr. Feig, that's the same thing as saying if Mr. Feig was picked first and Miss Harrod was picked second. So that's why order does not matter. But with permutations, if you had the president and VP, and if you had Miss Harrod as president and Mr. Feig as VP, that is different than if you were to assign Mr. Feig president and Miss Harrod VP. So that's when order does matter. Okay, and then one more slide of just depicting whether it's a combination or permutation. So if we're choosing two desserts, do they have different rankings? Does order matter? No, so it is a combination. And then you're listing your favorite desserts. If you're looking at this like it's like first and second, then it would be a permutation. But if you're looking at it as in like your top two favorite desserts, like they're having the same role, then it's a combination. But if you're looking at it this way for the sake of this, then that would be permutation. And again, on your quiz, it's going to be a lot more straightforward than this question right here. Now, picking a team of 3 from a group of 8, do they have different roles? Does order matter? No, so that is combination. And then if you're selecting president, VP, and treasurer, different roles, so order does matter, so permutation. Forming a kickball league, 5 of your friends, do they have different roles? No, they're all on the same team, so it's combination because order does not matter. Okay, oh, it looks like in this next one here, awarding gold, silver, and bronze, it looks like you're awarding different awards, so they're going to be different rankings. Order matters, permutation. If you're arranging 5 books on a bookshelf, like first, second, third, and that would be permutation because how you arrange those books on that bookshelf does matter. So that is permutation. And remember to make sure that you have all your homework, quizzes, and stuff completed. Do the review assignment. That will really help you guys because tomorrow you will have a time limit on your quiz and it will be on lockdown. So good luck.